Would you take a seat, please? We'd like to reconvene. Thank you. We always save the last session, the best for the last, and now we're going to talk about the commercialization of new technology, how you move the enormously challenging issue of how you move new technology out of the laboratory and into the marketplace, or in other words, how you traverse that green valley of death. And we've got a terrific panel to address various aspects of this from the university side, from the commercial sector, and also from the VC side. And we've asked Bill Barber to chair this. And I'll ask Bill and the speakers if they would come up now to the panel while I introduce Bill, who will take over from me. Bill is president of Maverick Angels and also co-founder and CEO of ISOmatrix. He's had more than 20 years experience in the management and corporate development experience, and also in the funding of especially new ventures at the angel level. And he's going to be our moderator today.
So, we have any entrepreneurs in the room today? One? Two. All right. I love this statement up here. Far better is it to dare mighty things, to win glorious triumphs, even though checkered by failure, than to rank with those poor spirits who neither enjoy nor suffer much because they live in the gray twilight that knows not victory nor defeat. Great entrepreneurial battle cry from a great entrepreneur, Teddy Roosevelt. So we look at Teddy and we think this is a great statement that really speaks to the unique nature and the unique thought process of entrepreneurs. But entrepreneurs as themselves aren't enough just to bring products to market. And so we're going to have a chance to talk about this a little bit. But the cool thing about Teddy Roosevelt is he wore a lot of hats, and they were very cool hats. Entrepreneurs wear a lot of hats. So I start out with this piece of my Jeff Foxworthyism for entrepreneurs. You may be an entrepreneur if your corporate to-do list includes high-level contract negotiations, deep market development, followed by vacuuming, dusting, and taking out the garbage. You may be an entrepreneur. You beg your spouse at inappropriate times of the day, may I please go back to work tonight. You may be an entrepreneur. You look at the 2009 global economic meltdown as nothing more than a great opportunity. Okay? And my favorite one, if you go to your priest, rabbi, pastor, and they ask you to describe your values. Describe your values for me. And you dive right into a discounted cash flow analysis. You may be an entrepreneur. So we have a chance today to talk about a couple of different things, and one of them is commercialization. I think it's a critical piece of the puzzle for investors and entrepreneurs to get together on. So I wanted to kind of throw out a couple of definitions here that we can kind of work within today, and then we'll be able to talk to our distinguished panel over here. So invention. I think, defining invention, I think, is a key piece of this as we go forward. We were looking at invention as being that search and connect piece. Within the patent law world, you look at creating things that are useful and non-obvious to those who are practiced in the art. The idea being, can you bring something that may have prior art out there in the market, bring together a variety of different pieces to create new inventions? That's great. Really, it comes down to the definition of creation that's resulting from study and experimentation. That's really the definition of invention. Then you look at innovation. It's a very different type of thing. Economics, you use the definition in economics that it's a change that increases value. The definition inside of the art field is maybe something that is substantially different. But really, we look at ideas that are applied successfully in practice, and that really starts talking to the concept of commercialization. We got a couple of young guys in these pictures here, Nikola Tesla and Thomas Edison. Nikola Tesla had some great inventions, a fantastic genius inventor, but had difficulty translating some of those into commercialization during his lifetime. Now, of course, we've seen a lot of those come into great use since then. Thomas Edison, on the other hand, had the ability to essentially affect economies through the inventions that he was able to innovate and bring to market, to commercialize. Very different. We look at translational research as well, and I want to define that as well. Inside of the life science industry, I think the idea of saying to improve human health, Scientific discoveries must be translated into practical applications. In other words, the bench to bedside conversation. How do you take something from invention all the way through to commercialization and use? And a great example of that is really here in our backyard, not too far down the road. Amgen took erythropoietin alpha and really moved that from being a conceptual precursor for red blood cell generation to a commercializable product, and a great success story in and of that. So commercialization, as you look at it from that perspective as well, the definition, the process or cycle of introducing a new product into the market, which really speaks to market validation, market drivers, things that really mean that the market is pulling, market is demanding a product or service, and you're able to supply that, to create it, develop it, produce it in a mass market sort of way and bring it to market. And I wish I would have used a Tesla example since we had Tesla here today, but I think it was very interesting to look at the Chevy Volt recently and see its introduction in the marketplace. The original concept car, if you look at it here, extremely dynamic, looks a lot like the Camaros, a little bit more, very herky, two-door type of sports coupe. Now as it's gotten to market, the market demands for the mass market deployment of that have changed the design. It's a much more four-seat, sedan-focused, mass market appeal type of vehicle now, really driven by the market validation, the market demand, and their ability to commercialize that, to bring it to market. So, in the investment community, we look at a variety of different things as you're going into the form of making an intelligent investment decision. These are some typical, these bubbles are kind of the typical areas of the diligence process. And it starts out with really defining that product or market, the product or service. Then what is the market size, the entry, and the demand from that market? How does it affect that product? And as you kind of wrap around this circle, these bubbles of the partners and collaborators needed, the barriers to entry, you see it's really about an invention can have one component of excitement, but nothing happens in a vacuum. You need partners, collaborators, you need a variety of different players in the market, a variety of different impacts from the commercializable market demands, and all those things come into play. As investors, we have to look at all of those different pieces to understand how the commercialization of a product or of an invention can go into being an innovative product of the future. And so we look at all these pieces. One of the most important ones at the very bottom, probably the most important one at the very bottom that takes almost most of our time, the management team itself, and the ability for that management team to get the resources it needs and fill the gaps in order to be able to reach out into the market, understand what's needed, bring those to market along with the product. So, very interesting piece of the puzzle here as we look at investment from the angel capital side. I have a good chance to be able to work with a panel here today that comes from a variety of different places, but entrepreneurial in its key focus as they look at how to take products through from concept, product development, into a launch or commercialization, then into profitability, growth, and the next steps. As investors, of course, we have to look at all these pieces, how they tie together, and how each one interacts with each other. As we know from a long history of funding different companies, no one funding source applies to a particular company, and therefore the different pieces of this puzzle are extremely important as you move through the life cycle of a company and the funding life cycle of organizations as well. So, that being said, I want to kind of quickly introduce our panelists here. Now, I'm not going to go through their entire bios here. You've got it right in front of you, and I trust that everybody's a great reader, so we're going to go with that. We've got really venture capital, entrepreneurship, commercialization, and really a great experience set here within the panel. So we've got Jim Dehlsen here, really working from the perspective of being the kind of regarded as the father of American wind power. So he's the principal right now of Ecomerit Technologies, but in the past he has built, deployed, developed, and sold Zahn Corporation to General Electric. He's built, developed, deployed with his son, Clipper Wind Energy, to UTC. And we're glad to have him on board here to really talk about some of the things that he's doing in the sustainability world, which is a great place to look at how you bring sustainable products through the commercialization process. Umesh Mishra. So we've got the CEO of Transphorm. He's got a PhD in EE from Cornell. He's a recognized leader in high-speed field effect transistors. He's been at the Hughes Research Labs, University of Michigan. He's been at General Electric, contributing greatly in all these different laboratories. And he's currently at UCSB developing novel materials use in the solar PV and the LED world also. Once again, translating and commercializing products as we go. And we've got KT Moortgat, a partner at Mohr Davidow Ventures. She has a doctorate in biophysics from some of her work at Salk's Institute and Scripps Institution of Oceanography. plus degrees, multiple other degrees from UC San Diego and Berkeley, and right now is an educator, along with her as a partner of Mohr Davidow. She's an educator of university entrepreneurs in specifically the area of commercialization, which I think is going to be a fascinating opportunity for us to hear from these different perspectives, different pieces of the puzzle that really add to the commercialization question. So, without further ado, Jim, if you start us out here.
Thank you. The topics that I'd like to cover start off really with wind. Wind is a very good example of, in the sustainability area, what's happened over the last 30 years in terms of how the commercialization has gone. So talk a little bit about the experience there. And then also the present environment for commercialization and what needs to change to really allow the U.S. to have the full benefit of the technology that we develop here. Then I'll get into a little bit of an overview on what we're doing now, which is Ecomerit. The renewable energy industry really came out of the energy crunch of the 1970s, and it had a very strong start in the early 80s, but there was discontinuity in energy policy, and by the mid-80s, the support for these renewable technologies was taken away, and it wiped out most of the industries. We were able to survive and win because we had a slightly different approach where we wanted to be a power producer, and we wound up owning bits and pieces of projects that we'd put together, and it allowed us to get through that very tough period. And what's interesting is that whereas the U.S. industry effectively collapsed during that period of the 80s and 90s, Europe picked up the pieces and implemented policies that created huge markets for these technologies. And so they, to a great extent, were able to reap the benefits of the work that the DOE and American industry helped to launch. And you can see that on-again, off-again policy in the graph on the right, where prior to that time period, from the 1980s until the early 90s, these industries were almost non-existent. Then they start to pick up a little bit, and in 2000, the support was pulled. It was extended for 2 years. It was pulled again. It was extended for another 2 years, and that's been essentially the way our energy lawmakers have conducted this business. And it's in a way akin to using the renewable energy industry as a trading chip to get other things that are needed or wanted by the bigger voices in the energy picture in Washington. So I think that until we get a consistent policy in place, it's going to be a struggle for American commercialization of technologies. We're very good at developing the technologies, but creating the market to really be able to deploy these technologies is a challenge. So the experience that I had was starting off with Zond, and we managed to survive into the early 90s, and at that point, we'd just seen the Gulf War. The DOE created some support again for renewables, and we applied with some ideas on technologies in wind that we wanted to move forward with. We got that support, created 3 generations of turbines, and still the financial markets in the U.S. weren't really behind renewables. So in order to get capitalized to be able to really take Zahn to the next level, I wound up selling a piece of it to Enron, and by 2000 they bought out the balance of the company. And actually it wasn't that they contributed capital to the business, but we were able to capitalize on their name. And at that time, back during that period, their name was quite good. So that allowed us to really bring the company up to the point where by 2000 it was the largest developer of wind projects and the second largest manufacturer of wind turbines. And then when they got into trouble, GE picked up the pieces in 2002. And with the machine that you see at the bottom, which we'd produced about 800 of, GE has gone ahead and they've produced about 20,000 of that particular turbine. In around 2001, we came up with an idea for how you can really scale up turbines to a much larger size. And the reason you want to do that is that as size goes up, your cost of energy comes down, but it hits kind of the bottom of that cost benefit range around 1.5 megawatts. And we had some ideas on how to do a drivetrain that would allow us to go to a much larger scale. And that's the image on the right. You can see the benefit with these images. The machine on the bottom there is a conventional 2.5 megawatt turbine. And with the reconfiguring of the drivetrain, we were able to create the same 2.5 megawatt size machine that's shown on the top. So there was a number of other things that went along with that, but that was a basic concept. And it was quite a bold move to really think that you could get into a fairly mature market with a new technology. The market at that point was around, I don't know, $10, $12 billion. With a new technology, well, it's in the energy business, it's not the machinery that's the product. The product is cheaper electrons. And if you can bring down the cost of energy, which we were able to demonstrate we could do with this design, we brought it down by about 18%, you will get a market. But in commercializing, there's other pieces that you have to bring into play. I think it's useful just to see the timeline on this because it was a fairly accelerated pace considering that this is big capital equipment and virtually nothing in the design of the machine is something that came out of a catalog. This was a new design generator. We introduced a permanent magnet generator, new controls, designed our own blades, pretty much the whole thing. And then for a startup company to be able to put that into production was a Herculean task with no supply chains having to get all that started. Anyway, we were able to do that. And we wound up testing the machine in early 2005. And still in the U.S., the capital markets were pretty weak on renewable energy. So we wound up going to the London Stock Exchange and did an IPO there. And we were able to start a production. Went into an abandoned facility in Iowa, 300,000-foot facility, started manufacturing and produced 500 turbines. And as was mentioned earlier, United Technologies bought that company in December of last year. The pace of this activity, I think, is a very key thing in the way we think about commercialization of sustainability related technologies today. We've got to move this stuff very, very quickly. And typically in commercializing this sort of activity, it's more than just manufacturing. In the case of Clipper, it was also being able to essentially create our own projects. We went around the country and back in 2000, 2002, 2003, there were a huge number of very windy sites that were available. No one was interested in wind at that point in the U.S., and we were able to build a very substantial portfolio. Also had to put together the ability to install and operate the machines. And then at the same time, if you're really going to carve out a leadership position with the technology, you better be thinking about the next generation machine. And we really saw the next generation as being offshore deployment. So we've advanced with the design of a 10 megawatt offshore turbine. It's about 450 tons on top of the tower. It's a 150 meter rotor and a 10 megawatt rating. That machine in its lifetime will produce the energy equivalent of the largest super tankers today, which is about 2 million barrels. Now, what keeps me moving is the urgency for getting this done. And number one, we're way beyond a sustainable yield of the planet by 50% according to some indications. Water tables are falling, glaciers are retreating, agriculture is right on the fringe now. We have a bad crop this year. It's really going to cause great problems on prices, and we're seeing hunger increasing from 800 million to about 1 billion now. It's on the rise. We're importing 2/3 of our petroleum, and we're in a phase where oil is peaking. So how do you go from 90 million barrels a day to the 120 million barrels that is going to be needed 10, 15 years from now? Climate change is intensifying. We're being told that to really stabilize climate at a 2-degree rise, we have to decarbonize by 80% by 2020. I mean, these are pretty formidable kind of things to face. And now this year we crossed 7 billion people on the planet. We're adding another 1.5 million people every day. And so it's no surprise that the number of failing states around the planet have doubled in the last 5-6 years. This is what, I hate to take you through this because you all know this material, but it's why we've come up with a different model than the Zond Clipper approach. And it's one of going to a development lab for sustainability-related technologies. And with the lab, our aim is to take it from the concept to essentially product certification. It's a different model than the earlier one where we take it all the way into commercialization, but the thing that's different today is that you have major corporations around the planet that want to get into this kind of area, but they haven't had their R&D focused on it, and there's just not a whole lot of ways they can do it. So I believe that with a development lab that can move forward 5 or 6 or a dozen technologies, there will be a way to hit commercialization with those. And that's kind of the basic idea of this lab. Right now, we're concentrating in five areas: marine energy, wave and ocean currents, bulk energy storage, production of potable water, green building systems, and combined heat and power. We believe that these technologies have the potential of being in certification in kind of a 4 or 5 year time frame. No doubt some of them will take 5 to 10 years, but that time frame is something that we've been able to achieve earlier. And so examples of this. This is wave energy. This machine, 4.5 megawatts, will supply about 1,500 homes. If you deploy 2 rows of these machines over a 20-mile stretch, you've got the equivalent power of a nuclear plant. And we've got a variant of this machine that produces fresh water. The wave energy resource is very large. You can see the circled areas on the map below. Mostly it's western shores, and a lot of those western shores have very dry climates, so it's the combination of being able to produce both power and water makes it an interesting area to engage in. The second area is ocean currents, and in ocean currents people generally think about tidal currents. What we're looking at are these steady ocean currents that are the big gyres, driven by the Coriolis effect. And there are some very large market areas that have these currents fairly close to shore. These are some of the areas that we've identified. We're in particular interested in the coast of Florida, where you go out 15 miles, you're into a current with a velocity of about 1.6, 1.7 meters per second. And the merits of this technology is that you have a steady flow, so you have a very high capacity factor. So you're essentially delivering base load energy at a pretty competitive price. To be able to commercialize this, you have to do all of the other things of really understanding the velocities and the profiles of the current that you're going into, and the environmental studies and grid connections and all that sort of thing. So all of that is part of what we do in parallel to keep within that 4 or 5 year time frame. So that is a significant market for this product. This is the Aquinas turbine, and you're now diving down into the depths about 50 meters below the surface. And those are 2.5 megawatt machines, very high energy density, and we believe that it can be something that we can bring to commercial use in about 4 to 5 years. So, in summary, I think there's elements of the market today that are very positive for commercializing. There's a huge entrepreneurial interest around the globe on sustainability technologies. Like I mentioned, big companies are interested in this, so there's a ready ability to absorb the technologies and take them into commercialization. And we have really excellent infrastructure in place now with the DOE labs supporting these efforts. Testing facilities that 5-10 years ago just weren't available. Today you have both in Europe and here. And a very key thing is the certification. To really get to be a commercial product, you do have to go through a fairly rigorous certification process. And we have a lot of engineering and science that has gone through decades of this sort of thing. So there's some very deeply steeped technical expertise available. Europe and the Asian governments are strongly supporting the move to renewables. China now, which just started 4 or 5 years ago in wind power, is now 50% of the production on the planet. And my final point is that sustainability technologies are going to struggle in the U.S. unless we can get our government to really be clear on the real costs of energy. If we know what the costs of energy are, not just from the direct costs, but the health aspects, climate change, the cost of the military, until you can get that out into the open, I don't think our ability to implement renewables is going to be what it really could be and should be, and that is an urgent change. Thank you.
Thank you, Jim. I think I can use a term that I think we can all agree with. That was awesome. Very cool. All right, Umesh, if you'd like to take the stage there. You can hear a little bit about Transphorm.
All right, I'll just grab something here. Well, thank you very much. It's a real pleasure and an honor to be here. I'm representing Transphorm today. It's a company here in Goleta, and we're pretty excited about what we're doing, and I hope we can convince you that what we're doing is actually useful. So our tagline is Reimagine Power Conversion. Power conversion is a process that has been happening since electrical energy was discovered. Reimagine means we are converting what is considered to be a staid and well-developed industrial sector. We're trying to sexy it up a little bit. What happened? Something happened, boss. You'll have to, yeah, that's great. Thank you very much. So, introduction to Transphorm. What do? We basically convert energy from one form to another. This is required for any electrical energy appliance. I call it an appliance. A supercomputer is an appliance. A washing machine is an appliance. So any electrical energy function will require us to do these things: convert either AC to DC, AC from the outlet, DC to the laptop, for example. DC to AC, this is an inverter application. Say this could be a photovoltaic panel, this could be power to the grid, this could be a DC battery pack in a Tesla or a Prius, and this could be AC to the motor that drives the car. DC to DC power conversion happens all the time. This happens also in a car where you take a battery pack and raise the voltage to another value. These conversions happen everywhere. It's ubiquitous, and the inefficiencies of conversion are hundreds of terawatt hours. Okay, and what we're trying to do, Transphorm, we believe, is the first company to address this at a platform level, and I'll explain what I mean by that. This is a little bit of bragging. It's an old slide, but basically the most important thing is that we have money to do this stuff. Okay, we've been funded by good VC firms like Kleiner Perkins Foundation, Lux, and Google Ventures. We raised about $38 million. We got voted as one of the best in clean tech startups in 2011. That's for you to judge, though. So the point that I try to make is that we are paying a hidden tax on electricity. It shouldn't be off. It should be on electricity. And if you look at the way electricity is generated in the US, there's so much in coal, over 50% in coal, natural gas, nuclear, hydro, wind, as Jim just talked about. And I'm still kind of in shock after his presentation. It's hard to follow him. But at the end of the day, of all the generation that occurs, over 10% of the electrical energy that is generated in the US is lost in conversion. This is about $40 billion of tax that we are paying, not knowing that we're paying it. That's about 318 coal power plant equivalents of energy that is just lost in conversion. I'm not talking about lost on the grid and stuff like that. This is lost in places like this, you know, the brick that you carry around in your laptop. Okay, so the important thing is, and I'm not trying to make a point of this other than making a point of it, is that the amount that we can save in electrical energy by eliminating these losses is more than all the renewables combined today. Okay, I want renewables to go up. I hope the statement is no longer fact in a few years, but it's a fact today. So want watts, waste not. Okay, so how much is a terawatt hour? So for example, San Francisco uses 6 terawatt hours of energy, all right? New York City is about 50 terawatt hours, and New York City and the suburbs, and Vegas is about 33 terawatt hours of energy, okay? So you can look at all this energy in the world, in the US, and the West Coast, all of the West Coast consumes about 270 terawatt hours of energy. The amount of conversion losses that occur today, and I'm saying Transphorm saving potential, assuming we get 100% of the market, of course we won't, but all the players in this space of electrical energy conversion efficiencies can save over 300 terawatt hours. This is equivalent basically to taking the West Coast off the grid, I mean, figuratively speaking. But basically, that's the amount of impact you have, which is enormous. Now, I'll give you a couple of real-life examples. First of all, you've got to make money doing this stuff, and subsidies are nice, and policy is really important, but if you can do it at least partway by making money, that'll be good. And the way you make money is either by amortizing energy efficiency cost, which means you tell the customer, hey, pay up now, and over the life cycle, you will get back what you pay now. That's a good proposition. The other is if you can provide value in form in addition to function. All right, I mean the kind of stuff that Apple does so well, for example, right? So if I told you that, look, I can take this brick that you carry around today and I can just make it vanish with my technology, you would pay a little money for it, more than the electrical energy savings that you produce. But the reason you can make it vanish is because you have made it efficient and you don't need to put the heat sink that makes it so big. So what ends up happening is at Transphorm are looking at places where the form plus function gives you the value. Another example is inside a hybrid vehicle. This is a Prius. And the nice thing about a Prius is that you have both a battery and an internal combustion engine, which the nice thing about it, it highlights the point I'm trying to make. You have two radiators in a Prius. Again, I'm going back to form plus function. So here's an internal combustion engine, and so you have your normal radiator cooling the internal combustion engine, but obviously that coolant is relatively warm. And then, in addition to that internal combustion engine, you have a second radiator. So a Prius comes with two radiators, right? Buy one, get one free kind of thing. And this one is the one that cools the power, but it's not quite free. That's the problem. This active cooling is for the electronics, this power unit that actually converts the battery power to the power that goes into the drivetrain. So we have two radiators. And the reason is you can't use the hot coolant to cool the electronics, right? So what we are trying to do at Transphorm is to basically affect this electrical power handling unit so that it doesn't need active liquid cooling. Okay, if we can do that, if you can make it by increased efficiency, then the most important thing is that the electronics radiator is removed. I agree with what J.B. Straubel said before, that it's not only the efficiency. If you do power electronics enhancements in efficiency, yeah, that's nice, but it's really the battery that matters. I agree. However, if you can get rid of the liquid cooling, you change the game, because there is nothing more valuable in a car than the space under the hood. Okay. If I told an engineer that I'm going to give you 11.2 liters of space, which is what a Toyota Prius uses, 11.2 liters of space, most of it is cooling, and I give you 11.2 liters of space, the guy's going to kiss you on the cheek. Right? So that's form plus function. So that's what we're trying to do. So what are the markets we operate in? We operate in really old school markets, okay? Industrial motor drives. This is as old school as it gets. But 50% of the electrical energy consumed in the US is used to move things, all right? Escalators, washing machines, you name it. So, and that's basically the following conversion. You take 230 volts of AC out, you go through a DC conversion and then go back to AC, all right? So you go AC, DC, AC. And in that conversion, there are losses of about 207 terawatt hours. Data server power supplies, this thing is going gangbusters right now. I mean, this is the power hog, which is increasing like crazy because of the web is, there's no end to it. And here, the power supply of the server, not the server itself. We can't do anything about that. That's more like John Bowser's gig, I mean, he can do these interconnects that can make the server get better. I don't do that. What we do is we do the power supply part of it. And there you can make these kinds of efficiency enhancements. As you can see, solar inverters, this is a very big deal. Solar inverters is going through architectural evolutions. Are we going to use a central inverter? Are we going to use a micro inverter, an inverter behind each panel? Are we going to use something in between? These architectures are developing, and as the architectures develop, the solutions will develop with them. But what you need is basically something that can plug into whatever be the architect's choice at the end. Electric motor inverter is basically 202 volts DC, and you step it up to 650 volts AC, and then you drive your 600 volts DC, that should be, then you drive your AC motor with it. So you can see where all these things happen. The markets are important, as was mentioned. You know, you really got to look at markets. At the end, you have to be in a business. The markets are, you know, and this is a conservative estimate. That is, I'm assuming that I'm going to only enter certain parts of this market that my technology, Transphorm's technology, can address. And there's $1 billion markets in almost each of these segments, in motor control, solar, data power, center power supplies, and there are more markets as well. Hybrid cars and in EV inverters, that market is small now, growing very fast. Okay, 5 minutes, I better move. So how do we do this? We use gallium nitride. It's the same material that is used for solid-state lighting. And gallium nitride, I won't go through the material properties. I'll just tell you that bigger is better in this case, all right? And gallium nitride is bigger than silicon and more, and can hold much better, can convert power more efficiently. There's a difference in the Mohr's law. We also have a Mohr's law in the power electronics industry, and it's different from scaling Mohr's law. What we value most is output power density. That means how much power can you convert per centimeter cube. And you can only do this if you're more efficient, because if you're inefficient, you can't convert power in a small volume because the damn thing's going to melt. So here what happens is it's a relay. The race is a relay race where you hand over from technology to technology, a bipolar transistor to an IGBT, and it's plateaued now. And now what is happening is that the device of choice is going to go into a different material, and we believe it's gallium nitride. Okay? So that baton is going to get handed over to Transphorm's GaN, everybody else's GaN, obviously. The nice thing about it is that we can get lots of breakdown voltage. You can see that we can get up to 2,000 volts. 600 volts is used in data server power supplies. 1,200 volts is used in electric vehicles, for example, and motor drives. 2,000 volts and larger is used in grid applications. All I want to say is that we can scale to large voltages. What do we do as a company? As a company, we decided that we are going to address everything, right from the material growth. This is all done in Goleta, in our company on Castilian. Gallium nitride technology, we have a fab, we make our chips, we make the circuits, we make the modules. And the reason is, in these new technologies, you can't just make something and hand it over to the customer and says, the problem is yours. What you have to do is, you've got to make sure that you can respond to customers at the appropriate pain point, because I will guarantee you, the first thing, and I can guarantee because this happened to us, you give it to the guy and he says, the thing blew up on me, all right? And so why did it blow up? We don't know unless, is it the material failing, is it the device failing, or the circuit itself failed? If you don't know all of this, you can't respond to the customer. We've done that. I'll give you a couple of examples. We just announced diode and transistor products. This is what is called a boost circuit. It doesn't really matter. What really matters is that it is 99% efficient, okay? So, which means I can convert from 200 volts to 400 volts with 99.2% efficiency. This is a big deal. And it tells you that Transphorm's technology is starting in these little pockets, but will go. And it's not only us. I'm using Transphorm because I represent Transphorm. It's going to be a multi-industry, huge new set of players. I just want to make one statement. It's not good enough to have a technology that is is basically, we cannot be a one-string band. You've got to have any technology in this expensive space can only win if it can provide multiple solutions, or economies of scale can be applied. And it should not be too disruptive. You can't make something so sexy that people can't use it. Right? So what we want to do is that we focused on, okay, this is a hard technology to use, let's make it simple for the consumer, and make sure that it has lots of applications. So thanks to Shuji Nakamura, Jim, and Steve, and all these guys who've really pioneered lighting so much, we have a $7 billion market in lighting, and it's growing. You need employees. That's where UCSB is so amazing. We train all these guys, and they're plug and play. You take them into you get them their PhD, and then boom, they're off and running, and they can lead the world. And this is awesome. Primit, who's the president, is a UCSB alum from 1996, for example. This is the sister market, $7 billion with the same material, gallium nitride. Okay, We are very thankful. We cheer them on all the time because the more successful they are, the cheaper the raw materials are for us. So we are their biggest fans. I'd like to end, because I know that Linda is like squirming in a chair right now. I'd like to end with the following statement that UC Santa Barbara, has been an amazing place, especially for me, and because this is my second startup, the first one worked out well, the second one I hope works out even better. Jeff mentioned the new kind of, I don't know what you use something for the new Silicon Valley, Energy Valley or something, and before that, we are in the gallium nitride valley here. It's the new material which has so many implications that we got to just keep developing companies in this area, in Goleta and Santa Barbara. And the philosophy of UC Santa Barbara is great. Do some things right, don't do everything average. Because the problem is, when you do some things right, you get people who are really well-trained, and because the marketplace is about the most brutal thing in the world. And you can't learn too much. I mean, you learn, of course, but you cannot learn too much out there. You have to learn to swim before you jump in. Administration is supportive. The technology transfer office has changed like crazy. It's a much more user-friendly office than it used to be. And the ONR has funded my research, our research in gallium nitride for over 15 years. And the way we started the technology, we started it by licensing all the technology we had developed at UCSB and patented at UCSB. Once with that base patent portfolio, we started inventing beyond that at Transphorm. So I hope that I've left you with an image of UC Santa Barbara is a great place to actually spin out companies. I hope more VCs stop by here. We are way better than Stanford. And we'll keep pushing things out the door here. This is where physical and material sciences, at least, I don't want to, CS and others can speak for themselves, but in my domain, I think it's awesome, and I hope we keep repeating the story over and over again. Thank you.
Hey, Umesh, thank you very much. That was a great example of how university technology can make it to commercialization. I think, just want to congratulate you here just on the reality that you're showing that in this kind of difficult space between prevention and the cure, efficiency versus energy generation, that venture capitalists can invest in that prevention piece, that energy efficiency, and by putting products out there that have multiple benefits, I think that's a great way to see that happen in the venture capital world. So we'll wait for KT to get all set up here, and we'll hear a little bit from the venture side. I think it was very valuable to be able to hear from two different entrepreneurs who have been able to kind of show you the been there, done that, been there, done that, been there, done that, and doing it again kind of mentality that serial entrepreneurs are famous for. So we appreciate both of those comments. Now we get to hear from the venture side. So KT, whenever you're ready.
Oops. Where's the, is there a pointer? Okay. All right. Okay, got all the technology now. I'm down. I'm KT Moortgat, and I'm on the investment team at Mohr Davidow Ventures. Was honored to also be called an educator, but primarily I'm on the investment team at Mohr Davidow. I'd like to talk to you a little bit about the venture capital perspective on innovation and commercialization. I'll just give you a little bit of background on Mohr Davidow, where we come from. I want to talk to you about the financing path. We've talked about components of this in pieces. I'd like to kind of cover the whole thing in clean tech innovations. What I see as some of the landscape for today for financing, and then what we at Mohr Davidow are looking for in our future investments. Just briefly, we've been investing for 28 years now in early stage venture capital, in early stage companies. We have about $2 billion under management today, and we're investing out of our 9th fund, which is a $700 million fund. We're very much thesis-led. It means that we think about the world before we take on new investments. So we define areas where we think there's really that are ripe for market changes, and then look for the disruptive technologies that will address those. We are investing across 4 different areas at this point. Clean technology is one of them, as well as life sciences and infrastructure IT and digital media IT. Something that really marks us, and part of the reason why I think I'm here today is at UC Santa Barbara, is that we really look for true innovations. We're looking for very early stage new technologies that can really pioneer markets. We are hands-on, and we truly believe, as I said, that innovation lies at the core of venture returns. This is not every venture firm follows that, so just really want to emphasize that. And through that belief in innovation, we spend a lot of time at universities, and I don't want to spend a lot of time on this slide, but I do want to emphasize that we as a firm are affiliated across a variety of different institutes in all of our related to all of our investment areas. And I just want to give you a sense of that, as well as a program that I manage on behalf of Mohr Davidow to fund innovation at universities. Specifically, it's at Berkeley and Stanford right now around clean energy technologies. But the idea really is to fund pre-tenure faculty who are already entrepreneurial, who are already taking sort of very disruptive approaches in their fields. And some of them, actually, you'll be happy to see, Umesh, you may recognize some of these faces because there are several UC Santa Barbara graduates, actually. It was sort of a remarkable finding amongst this group. So delighted to be supporting innovation through this means. Our view on the need for clean technologies, which I'll get into in more detail later, has led us to early investments in solar, including in NanoSolar, a thin-film solar company, and some other solar companies. I'll also touch upon Recurrent Energy, which is a solar development company. I'll talk about that a little bit later. We also were early investors in the biofuels and biochemical space. Biochemicals really where we see higher value end products. And I'll talk to you again a little bit later about OPX Biotechnologies. We have several investments in our portfolio that also really touch on the resource demands and the resource constraints that we're seeing in the world through all the things that Jim and others have been talking about today. And then a lot of interest in energy efficiency plays as well. So let's look at this financing path for clean technology innovations. As we said, we've talked about different components, different slices of the value chain, of the innovation to commercialization value chain. We heard from folks here at UCSB who are developing new inventions and innovations. We've heard from the folks at PG&E who are looking for the final commercially ready final product that can be deployed at scale. And we're looking, what happens in between those 2 points. So this is a figure that was put together by some of my partners at Mohr Davidow, Will Coleman and Josh Green. And it really shows the capital needs of a clean tech company from innovation to commercialization. So, and then along with not just the needs, so this is capital required, and this is time or stage of development. And you can look, you see here across research and development. I'm not sure how well you see this in the back, so I'm going to just walk you through some of this. Research and development stages, commercialization phase, and then really sort of large-scale adoption phase. So I think that if you walk through this, starting from the research side, you'll see that there's clearly in this purple zone here, there's relatively good amount of funding for the basic research, for applied research that leads to some of the new inventions that are key to the clean technology future. There is on this graph are highlighted a couple of different gaps in funding. So I want to emphasize to you that there is this initial gap here from applied research. A lot of people call this the valley of death. Certainly, we talk about this a lot as being a valley of death in terms of innovations leaving the universities. There are others that come later on that are actually critically important, and that we as venture investors pay a lot of attention to the ability of these later stage financing opportunities to be available and accessible to the startups that we're investing in. Without them, we're not able to, the company's not able to scale, and we're not able to get the returns that we demand and that our LPs demand. So walking through the steps then, a lot of times as you get to later stage in terms of demonstration scale, commercial scale development, you'll continue to be seeing venture investors playing at that point, but you're starting to see a step in of private equity, corporate partnering, and over time, debt and project finance. So basically what I want to convey is that here you see venture capital, which I think we think of oftentimes as being a pretty large player in this, and clearly a critical player in this in the first launch of the company, over time is being dwarfed by some other really major capital requirements. So the good news for clean tech innovation is that the partners that are coming in at this corporate, the corporate partners and the like that are coming in to really bring this up through commercial scale are returning to the table for innovations whose technical and economic proof points have really been demonstrated. And I'll give you an example of this. The other good news is that government grants are coming in. The government is taking a role in both the policy side, putting in place RPS, Renewable Portfolio Standards, and also funding both at the early stage, through ARPA-E and the like, and then later stages through loan guarantee programs, which have been really instrumental for several of the companies, including we heard from Tesla earlier. When I look at this graph and I look at this little spot right here that is really the focus of so much of where venture capitalists sit initially, is looking through the inventions that are coming out and then deciding where they're going to deploy all of this funding and how to help those companies actually capture into here. It seems really rather daunting. And I have to give both of you credit. I mean, this is really tremendous what James and Umesh have been able to do in both their areas. But really, at this point, with wind really being way out here in the full adoption side. But lest this seem an impossible set of hurdles to overcome, we've certainly seen examples already. And I'll give you an example of a biochemicals company, OPX Biotechnologies, which is in our portfolio at Mohr Davidow. One of our co-investors is here actually from Exceed, and you can raise your hand, Rob, out there in the back. OPX is a company that has a directed evolution biotechnology platform that has been applied to the production of bio-based acrylic acid. Now, they offer a direct replacement in an $8 billion market for acrylic acid. If you look at how they've played this path, which is going to demand tremendous amounts of capital for them, they've been able to get ARPA-E funding, so government funding for some of this early, so non-dilutive early capital here in the venture capital to augment their venture capital raises. And most recently, they've come in here with what's maybe what looks like a very small slice of this pie today, but actually amounts to be tremendous in terms of being able to create a corporate partnership. It was just announced 10 days ago with Dow, which is the world's largest producer of petroleum-based acrylic acid. And together, they're going to be leading the scale-up of their product, their bio-based product. Accessing these financing options are key to enabling access to public markets, right, and which in turn offer additional capital to the companies as well as provide return to the venture investors and stimulate that investment to begin with. So I want to give you a little bit of a sense of today, what's the landscape for for both investments, venture investments into these companies, and then the exits on the exit side. And just to give you a sense, this is all around clean technology investments, so venture investment in North America. You're looking here both at the number of deals in the red or orange or whatever that color is, and then sort of in this bright green, the dollars. And clearly, venture capital in clean technologies is very robust at this point. We're talking about almost $8 billion in 2010. And we had a record in Q1 2011, a record high raise of about $2.6, $2.7 billion globally, which is a 13% increase over a year ago. We're also seeing a lot more capital going into each deal. And that's just one thing that we have to be sensitive of. Again, looking back to how do we actually get our return on those things, on those investments. I thought I'd share with you a little bit of where those dollars are going into. And it's probably hard to see it from the back, but basically there's a color coding here of a whole suite of different investment sectors, from water to agriculture to smart grid, energy storage, and the like. And really, you see two kind of hop out right at you from late 2009 to early 2011. You see that solar and energy efficiencies are really at the top of the pile in terms of numbers of deals that are being done in venture capital investment. So the money's going in, and the good thing for all of us, money goes in when there's a chance for it to go out, and it is able to get out now. There was a very bleak point there for a while in the 2008-9 time frame, but we are back into the good zone, and definitely have seen not only good IPOs, but also robust in the sense that they are maintaining their value. So if you look at Amyris, for example, they've been able to actually, do the IPO and raise the public funds that way, but also to bring their stock value up by about 70% after the lockout period, which is great. If you look at M&A, which is another sort of draw, that's the other side of being able to pull the pulling side, and so we also see a lot of activity in M&A, and that's really important for us to see. So that kind of gives you the big global picture. I'm going to talk in a moment about the picture at Mohr Davidow and sort of how we think about the drivers for investment. But I want to just spend one moment, since we're at UC Santa Barbara, and just talk a little bit about what we see on the university spin-out side, which is really that folks are so familiar. This is really the core of what's being done at the universities, is the faculty and students research and leading to invention. As soon as that invention happens, though, there's sort of this whole explosion of things that happen that that I think the faculty and students aren't entirely set up for. There's a disclosure to the licensing office that may lead to a patent. With that patent filing, though, there's all these questions about, well, what exactly is the application? And with that, then how can you go back and characterize the features of that invention, design a prototype, assess, well, really, what is the opportunity? And you kind of start bouncing around in this whole world of all these unfamiliar area. And I just think that this is an area where I believe, if I can just throw in my 2 cents here, that I think that universities really have a critical role in enabling faculty and students to make it through that, such that they have validated technologies, a clearly defined market opportunity, and a team that can get funded like Umesh's startup has. So just to give you a sense, I think that I actually, given the interest of time, I'm just going to kind of pop through this one. But basically, market, technology, and team are the key components of what we're looking for. I think that's pretty standard, but I'm going to talk to you a little bit about what Mohr Davidow puts on top of that, given this picture of what are the financing needs in clean technology. I think there's 4 areas. We talked about that market opportunity. It has to be really massive. Clean technology often does not have a problem with the big opportunity. We're talking about massive industries, and so this is what happens, though, is that those massive industries are not always very readily accessible by startups, and that's the key. That's the differentiator, I think, in clean technologies that we're looking for. How does this technology have access to markets to these well-established markets. Part of that comes from the team. A lot of times what we see is that a team is really the difference between being able to create the corporate partnerships, like what OPX did, be able to create those corporate partnerships and be successful. So in general, we're looking for relatively low capital intensities or a mechanism for accessing the capital, a mechanism and a plan and a team that can access the capital needed. So just to give you a sense of what we're looking at specifically at Mohr Davidow, we really, I think that, this has been laid out very nicely in prior talks, but I think there's very strong strain on our available resources, both in terms of energy, in terms of agriculture and food, and we're seeing that is really driving this proliferation it's driving up costs, it's driving up volatility for conventional sources of energy, and it is creating enabling economics that are for renewables. We're also seeing technology innovation that, whether it's in material science, like what we've heard about here today, or a diffusion of IT solutions that have been out there that are creating this opportunity. And so this is really the macro view that we have of these enabling economics plus technology innovation, where we see driving alternative energy solutions, in particular in the area of the electrification of our lives. And when we look at areas that we can, in that electrification, looking at both the energy supply side, the supply of that energy, of that electricity, the demand, and being able to modulate the demand, and then being able to integrate. A lot of that integration can actually happen through energy storage and other applications and new technologies that can help mitigate the need or the supply, the demand side, and reduce the supply requirements. So, there we go. So just to give you a sense of where we're specifically looking, we're combining those views on these macro trends, along with the need for venture capital returns within a reasonable capital intensity. And we are looking in areas that are solar. So we have investments that are currently in the module and developer side, but I didn't mention the recurrent, but I can do that in a Q&A if there's an interest in the M&A and that area. But what we're looking for going forward is either ultra-high efficiency materials in solar, also balance of systems, power electronics, things that can help make that the conversions more efficient, very much along the lines of what Umesh was talking about. A lot of interest in the smart grid, both in being able to monetize data, building intelligence, and the like. And then on the storage side, we really see storage as a critical component and be able to bring those renewables online at the grid scale. And a lot of that is then driven by the markets, the earlier markets in the auto. So I hope that gives you a little bit of a sense for where our interests are today, and I'd be happy to take questions.
Okay, just a quick show of hands. How many people are going to have questions in the room for these three panelists up here? Nobody? Just a couple dozen? All right. So if we can pass out some microphones here, and so I'll get a chance to kind of ask the first question. But before I do, I think we got one right here, and I just want to point out to Jim. I'm looking at your wife over here. I got a chance to meet her at the reception the other night. She's so proud of you. She's smiling. Just great. So let's start with the first question right here.
Yes, hi, I'm Craig Shields from 2greenenergy.com. I thought this was fabulous. I thought you guys did a fantastic job. Jim, you closed your magnificent talk with a reference to, I guess, what we call internalizing the externalities. In other words, the concept that if we're not forced to pay as we go, we're in a world of hurt. You're closer, I believe, you must be somewhat closer than I to the Washington scene. It seems to me whenever I bring this up, I get a blank stare. Do you think there's any trajectory for a world in which we force those who generate and consume energy to deal with things like the healthcare aspects, the long-term environmental damage aspects, et cetera?
You know, it strikes me that it's going to be brought about when the threshold of pain is strong enough. We've responded very well when there's been crisis, but as soon as you know, oil goes from 140 back down to 80 or whatever, everybody goes back to sleep. And I just you know, I think we're kind of at the end of having time to bail out from some of these difficulties. So it will be, I think, America recognizing that we're in a very serious situation, and at that point, I think the response could be very strong. But you know, unless there's pain, I just don't see it happening.
Pain first, always. Jeff here, and then we'll go in the back. Yeah. There's a microphone right there.
Totally aware, roughly.
Can you grab the mic there?
Roughly, when you showed the chart of all the investment, number of deals, and it's certainly impressive this last few quarters, it's really picking up, it seems. What would you guess the percentage of those deals there's a subsidy involved? Or for instance, Umesh, I assume you're probably trying to do something that doesn't need to be subsidized because it's just save energy, blah, 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 right? So is a lot of these deals you're investing on the assumption that these are still not economic and need subsidies, or are you working on a lot of niche things that actually aren't going to need any kind of subsidy? They can just stand on their own.
Our investments are specific, I'm not sure which mic I'm using, but our investments are made such that they do not require, the economics do not require subsidy. We will certainly seek to benefit from them. The companies certainly seek to benefit from them. But the fact is that the availability of a loan guarantee enables tremendous, a tremendous boost to those who can get it. So I think that it's something you definitely want to leverage.
So you leverage while you've got it.
Yeah.
Okay, let's go in the back.
Good afternoon, or good morning, Ed Kuros, Emerging Markets. So one general comment and then a question for Jim. So a general misconception is that a pioneer is the guy or gal with the most arrows in their back. And I think you guys sort of redefine and contradict that, and I think that's tremendous. So for Jim, the question I have is, as wind development and marine renewable energy moves offshore, talk a little bit about the supply chain that needs to be developed, and then what are the material science challenges that the current wind technologies really don't address?
The thing that we're seeing with these renewable technologies is because the components are so large, there tends to be a big transportation component, cost of transportation. I think as offshore wind takes hold in the U.S. on the East Coast, it will stimulate our supply chains in the U.S. to serve that. And we're seeing a fair amount of that actually in the Midwest now, where with large turbines, a lot of the steel supply and the supply of major components, big castings, that sort of thing, starting to be done in the U.S. again. And it's only happened in the last 5 years or so. So it really is, it's kind of an optimistic thing for the rebirth of heavy industry in the U.S.
We just heard a note this morning on NPR that durable goods manufacturing has gone up in the U.S. For the third month in a row here, so it's also a good piece of that puzzle.
In terms of materials, with the marine hydrokinetic effort that we're on now, we believe that a lot of the materials that are used for offshore and that have been adopted by the maritime industries are very, very suitable to what we're doing and should be able to get us into, at least into a commercialization kind of phase. I'm sure there's going to be a lot of improvements on that, but there's been some really excellent advances from those areas that we're benefiting from.
Okay, we got a couple more, maybe one or two more questions. The microphone's right there, yeah?
Yeah, just a quick one for Umesh. What was the time scale at which those terawatt hours of energy waste numbers were based on? Was it over a course of a year or a month?
Yeah, that was an annual savings.
Okay, and that was the same scale for all of the figures were based on?
Yeah, all those figures for New York City and all annual energy consumption.
Thank you very much.
Okay. Go ahead.
C.E. Beaumont from Emerging Markets and Technology Report. Jim, you talked about the fallen states ramping up from 7 to 15, I believe it is, as of last year. The pain versus planning and implementing, that is my question. When do we shift from this idea of going from crisis to crisis, feeling the pain, to long-term planning and implementing?
Well, I believe we just have to be very, very close to having that happen. You know, Jeff has talked about being optimistic. I'm optimistic, actually, notwithstanding that list of things that look like we're, you know, really at the tipping point. I think we have the technologies and we have a fairly deep understanding now within industry and business as to what needs to be done. And we're seeing capital shifting in that direction. The hard thing, I think, is that this nation has been brought up on cheap, abundant carbon fuels, and that changing that course is difficult. But I think the failure is that it's viewed as kind of an all or nothing thing, where either we're on carbon fuels or we shift over to renewable energy kind of things by the carbon fuel folks. And I wish they would just relax a little bit and let these industries flourish, because there really is room for everybody. And 5 or 10 years from now, their children are going to be asking them, why didn't they, you know, take on a more relaxed view on renewables. So I don't know. I've been struggling with it for decades now, and I think it comes back to that. It's just a culture that is very single-minded on the carbon fuels as a way to go.
It's a tough question in a short period.
The Department of Energy, I got to tell you, has made a very big change, and I think there's great hope that will be more supportive, and it really comes from the labs, where there has historically been support for a transformation. The challenge has been at the higher levels and really getting movement.
Yeah, tough question to answer. Tough question to answer in less than 3 hours, I think.
Yeah,
in that
that's
particular
right.
case, that's a tough one. Okay, let me ask two quick questions here. KT, as an educator of entrepreneurs, what's the most important thing that you find yourself telling entrepreneurs who are coming out of the academic world and moving into commercialization? What's the most important lesson that you have to translate to them?
I think the biggest one is to be aware of who your customer is, who your audience is, whether it's the investor, whether it's your, whoever's going to be buying the product that you want to build, is to really understand what are their needs, what are they looking for. I think this is standard, I think I see a lot of smiles because maybe it seems kind of funny, but I think a lot of us are so, wed to our babies we have to be able to see it from the other side. How is
From
the
the customer's
receiver?
perspective?
Yeah.
All right, great segue into the next question for Umesh here. Your customers are the OEMs, the manufacturers of the products, but your end users are not necessarily the buyers to you, the payers to you. When do you bring them into the conversation on the design side?
Yeah, we basically, we remained in stealth for 4 years because we thought that the best thing to do was to bring them in right up front. But what they have to be are very open-minded customers who can feel your pain and walk with you. So we had customer partners from day one, and so we've been designed in, but it takes a long time, and the earlier you get into that mode, the better it is, because there's a law of conservation of whipping you're going to get from the customers, and you might as well get it out of the way.
Get the whipping done early. Okay, I think we're to the end of our time slot, and I know that there's some snacks waiting for us and other things. So David, I'll turn it back over to you.
Terrific panel.